It's another exciting day here in Algebra 2. We are starting factoring today. We will be doing multiple days of factoring, but we are going to ease into it with 3 different parts. So first of all, what are factors? Factoring an expression changes it from the sum of multiple terms into a product of 2 factors. Remember, product means multiplication. So here I have changed this from the sum of 3 terms into the multiplication of 2. So one of the ways that you can factor is just by taking out the GCF, also called the greatest common factor. So when you're doing this, you need to look at the coefficients, the numbers in front, whatever the common factor of your coefficient is, you can take out. And then also for your variable factors, so whatever the lowest power that's common to all the terms, you can also take out. So here are some examples, starting with 16y squared minus 24y. Looking at just my coefficients, 16 and 24, I can take out an 8. That is the greatest common factor between 16 and 24. And then between y squared and y, I can take out y to the first power. What I will be left with is, if I were to divide this term by 8y, what is left over? And that would be 2y and then minus 3. And the way you can check to make sure you have factored correctly is if you were to distribute this back out, you should get what you started with. Okay, looking at B, between 12 and 28, I have a GCF of 4. Between x squared and x, I can take out an x to the first power. And between a y and a y squared, I can take out a y to the first power. What that will leave me with is 3x plus 7y. And again, you can check that you've done this correctly by distributing, and you should get what you started with. Okay, on C, I have 3 terms, so anything I take out has to be a factor of all 3. So I've got -8, -6, and 4. That means I can take out a 2. And I can also take out a b. I cannot take out a because it's only in the first 2 terms, but I can take out a b to the first power because it's in all 3. So what that will leave me with on the inside is -4a minus 3ab plus 2. Another thing we could have done is factored out the negative, and if I had done that, I'd taken out -2b. What that would have done is changed the sign of everything on the inside. So either way, that's still factored, and again, you can check that you've done this correctly by distributing it and make sure you got what you started with. Last one on D, between -10 and -5, I can take out a -5, and then I've got x to the 5th and x, which means I can only take out an x to the first power, and that will leave me with 2x to the 4th plus 1. Again, distribute to make sure you have done this correctly. Some special cases with factoring are trinomials in the form ax squared plus bx plus c. This is called a trinomial because it has 3 terms. And what we can do if these are factorable is something called the x method. And remember, a, b, and c refer to your coefficients. So when you're doing the x method, in the top you put the product of a and c, so a times c, and in the bottom you put your b value, the middle coefficient. And then what you're looking for to find m and n are 2 numbers that multiply to your value at the top and add to your value at the bottom. Once you know m and n, you can rewrite this as the product of your 2 factors. So we are going to look at the case just when a is equal to 1 for now. Next time we'll look at when a is greater than 1 because the steps are slightly different. So starting on this first one, x squared plus 7x plus 10, this means that a is 1, b is 7, and c is 10. So a times c is 10, b is 7. So I need 2 numbers that multiply to 10 and add to 7. Well, that is 5 and 2. So this tells me my 2 factors are x plus 5 times x plus 2. Now I could multiply this back out to make sure I factored correctly, and remember this would mean that you are FOILing if you do it that way. And I do get the trinomial that I started with. Okay, moving on to the next one. On this one, a is 1, as they will all be, b is 3, and c is -28. So a times c is -28. My b value is 3. I need 2 numbers that multiply to -28 and add to 3. Well, that is 7 and 4. And the 7 is the one that needs to be positive because I end up with 3, and the 4 needs to be negative. Positive 7 minus 4 gives me positive 3. So my two factors are going to be x plus 7 and x minus 4. Again, I could FOIL this to make sure I get the trinomial that I started with. Moving on to this one, a is still 1, b is negative 11, and c is 18. A times c, 1 times 18, will give us 18. B is negative 11. Two numbers that multiply to positive 18 and add to negative 11. So if they multiply to a positive but add to a negative, that tells me both of these numbers need to be negative, because a negative times a negative is positive, but a negative plus a negative is negative. And those two values are going to be negative 2 and negative 9. So x minus 9 times x minus 2 are going to be my two factors. Last one, a is still 1, b is negative 8, c is 15. A times c gives us 15, b is negative 8. So again, I need two numbers that multiply to a positive number but add to a negative number. So that means they're both going to be negative. And if they multiply to 15 and add to negative 8, that's going to be negative 5 and negative 3. So my two factors are x minus 5 and x minus 3. And again, on any of these, we could FOIL to make sure we got what we started with. The last special case we're going to address today is called the difference of two squares. So when you have two perfect squares that are being subtracted, like a squared minus b squared, this has a special formula for being factored. Whatever the square root of a squared is and the square root of b squared is are how you determine a and b. And what this factors out to is a minus b times a plus b. And the reason that this factors into the difference of two squares is because if I were to FOIL this, I would get a squared plus ab minus ab minus b squared. What happens is that middle term cancels and you're left with a squared minus b squared. And the way to recognize when you have differences of two squares is to memorize your perfect squares. So whenever you see binomials, two terms, you want to identify, could this be a difference of two squares? So we are going to go through these examples here. On A, I have 25 minus 36x squared. So if this is a squared minus b squared, that means that my a is 5 and my b is 6x. So factored, this would be 5 minus 6x times 5 plus 6x. And I could FOIL to make sure that I get what I started with. On B, I have 49x squared minus 64, so that tells me that my a value is going to be 7x and my b value is 8. So my factored form is going to be 7x minus 8 times 7x plus 8. 36a squared minus 25b squared, that means that my a value is going to be 6a and my b value is going to be 5b. So 6a minus 5b times 6a plus 5b are my two factors. And then lastly, 4x squared minus 121y squared. My a value here is 2x. My b value is 11y. So my two factors are 2x minus 11y and 2x plus 11y. And again, I found each of those a and b's by square rooting the perfect square. And again, the nice thing with factoring is you can check your answer by multiplying it back out to make sure you got what you started with. We will continue factoring next class.